Good morning, guys, and welcome back. We are doing today 5.1 day 2, continuing to simplify trig identities and expressions. I just wanted to say I'm very impressed with how you all did yesterday. Keep up the good work. So at this point in the lesson, what I would hope you would do is check over your homework from the night before on the answer key that I posted this morning, and also fill out the survey on how you did on the homework. And what we'll do now is we'll do some examples, and then I'll give you a few more problems. The examples we're going to go through today, we'll still use that same identity sheet that I gave you, and we're just going to do some more practice. I wanted you to have a few more examples available to you. Okay, and I will also post the worksheet for you to do and tell you what problems you have to after we're done. So let's get going. So for our do now today, which of course I always want you to try on your own, and it's just using those same trig identities. We're continuing to do the same thing. We have simplify cosine times secant. So at this point, I ask you guys to always do the same thing. Always, always, always put in terms of sine and cosine. So in terms of sine and cosine. Ignore my writing. My stylus is a little bit wonky today, so we'll see how we do. It says simplify cosine times secant. So what I'm going to do is I'm going to go back to the identity sheet. I see that cosine is already in terms of cosine, so I'm going to leave that alone. But what I am going to do is I know that secant is equal to 1 over cosine. So I'm going to replace secant with 1 over cosine. And just like we saw a lot yesterday, what happens when we have cosine on top and bottom? We know that they can cancel. We're just left with 1 over 1, which is equal to 1. And just like yesterday's notes, I have posted these worked out solutions as well. So if you rather than going through the whole video again, just want to look at the notes, you can. So that's our do now for today, getting back into what we're doing. And all of these examples, they say example 1/practice, because we're not really adding anything new today, just a continuation of using those identities and simplifying. So our next one, again, just to go through another example, we have sine theta plus cosine times tangent. So I'm going to leave sine of theta alone, and I'm going to leave cosine alone. Doesn't mean that you're going to leave them alone the whole time. It's just that you want to see, for now, let's leave them and see what we can do. Tangent, on the other hand, I'm going to turn this in terms of sine and cosine. So we know that tangent is equal to sine over cosine. It's one of our identities. So I'm going to replace tangent with sine over cosine. Now at this point, I leave the sine out in front, and what I can do is I can cancel the cosines because there's one on top and bottom. Now let's step back for a second and talk about algebra. If I told you guys to solve or simplify x plus x, you would tell me that that was 2x. Well, trig functions behave the same way. If I have sine plus sine, that's what I'll be left with after they cancel, that will just end up giving me 2 sine of theta, and that will be my final answer. Okay, can't do anything with that, can't simplify it, so we just leave it there. Remember, if you guys have any questions, feel free to ask me as we are going through. Okay, our next example says simplify sine of theta over cosine of theta tangent of theta. Now this looks awfully similar to the last one, except now we're dealing with some division. Again, I'm going to want to try to put everything in terms of sine and cosine. So, I already have a sine and a cosine. I'm going to leave them. But what I am going to do is just leave the top alone for now and see what I can do on the bottom. On the bottom, I'll keep the cosine, but again, I want to turn the tangent into terms of sine and cosine. So what is tangent? Sine of theta over cosine of theta. Cosine is over 1. What happens when we have the same thing on top and bottom? We have a cosine here and a cosine there. they cancel. So this whole time I'm just going to carry along the top, so I just have sine of theta on top, and on the bottom I'm just left with sine of theta over 1, which is just sine of theta. Now again, what does this simplify to? Let's step over to the side for a second. If I asked you, what is 5 over 5, I would like to believe a lot of you would tell me 1. Anything divided by itself is 1. Sine divided by sine is therefore just equal to 1. Okay? This whole thing will just simplify to 1 in the end of the day. Take a second, stop if you want to look back at the last few examples. Okay, let's continue on from here and get these last examples in. So now I threw in example 3 because what we have here is 3 terms that all have squares in them. And I said whenever you see a squared term, try to think identities. Okay? Anytime you have sine squared plus cosine squared, you're going to look at your sheet, even if they're not next to each other, even if it was sine squared plus tangent squared plus cosine squared. Any combination of sine squared plus cosine squared is always an identity. It's that Pythagorean identity, and it is just equal to 1. If you check your identity sheet under Pythagorean identities, it's the first one on there. So sine squared plus cosine squared boils down to 1 plus tangent squared. Now here's the thing. And you know what, let me write that a little bit neater so you guys can definitely read it. So this would just be 1 plus tangent squared theta. So now at this point, I have 1 plus tangent squared. That looks awfully familiar to me. So I'm going to look at my identity sheet. And what do I see in my identity sheet? That 1 plus tangent squared is actually another Pythagorean identity. Okay? 1 plus tangent squared is just equal to secant squared theta. So that one was just straight. Whenever you see a squared, try to look for identities. And that was like your last homework problem last night, number 4, that some of us had trouble with. That ended up just being a Pythagorean identity. We struggle with that a little bit, so make sure you go and look at that answer key and make sure you understand number 4 now. Okay? Kind of goes with this idea about the Pythagorean identities. Okay. And again, if you need to pause this, stop, go back, you can of course do that. And let us get to our last example, and then I'll talk about your homework for tonight. So our last example on here just says to simplify cosine of theta times 1 plus tangent squared theta. Okay? So again, before you do anything, I know we talk a lot about, taking things immediately and putting them in terms of sine and cosine. So maybe you're thinking, okay, I'll turn tangent into sine squared over cosine squared. In theory, that would work. But whenever you see a 1 and a trig function squared, look for an identity. It won't always be an identity, but a lot of the time it will. So if we check our identity sheet, 1 plus tangent squared, we just talked about it, is secant squared theta. And then we have the cosine still outside. So this right here is just a Pythagorean identity. And now we have to simplify this. Okay, so here's something that we haven't talked about too much yet, which is, what do we do with cosine and secant squared? So secant squared is 1 plus tangent squared. I'm not going to write that because then I'd be working backwards. So what can I do with the secant squared? Well, when I see cosine and secant, I know that they are reciprocals. So I'm immediately thinking, how can I maybe get something to cancel? So I'm going to leave cosine alone, but what I'm going to do is rewrite secant squared in terms of cosine. So I know secant is 1 over cosine. So then what's nice with identities is if I'm talking about secant squared, it just simply would become 1 over cosine squared. If I'm talking about maybe it's sine squared, or maybe I should say instead of sine, we'll use the more obvious one. Cosecant squared, that's just 1 over sine squared. Or even the reciprocal identities. So tangent squared, that's just sine squared over cosine squared. They work the same way when they're regular as when they're squared and tripled and so on and so forth. So rather than, secant being just 1 over a regular cosine, it's secant squared, so we replace it with 1 over cosine squared. And I'm going to get rid of these little identities in the bottom so I don't confuse us with this example. So again, we replaced cosine times 1 plus tangent squared. We replaced the 1 plus tangent squared with secant squared. And then we wrote secant squared as 1 over cosine squared. So cosine is over 1. So what's going to happen here? Well, if I have 1 cosine on top and technically 2 on the bottom, the 1 on the bottom would cancel and the 1 on top would cancel. So what am I left with? I'm left with the 1 on top, and then I'm left with just a single cosine on the bottom. Let's connect that if you're confused on that step. So this next step, if I simplify it a little bit, would really be cosine of theta over cosine squared theta. So just like, for example, if I had x over x squared, the x on top would cancel, one of the x's on the bottom, and I'd be left with 1 over x. It's the same idea here. I have a cosine on top, I have 2 cosines on the bottom, so the 1 on top will cancel and leave me with a placeholder of 1. And then the 1 of the cosines on the bottom will cancel and I'll just be left with 1 over cosine. Now if you look at your identity sheet, I don't want to leave this as a fraction. So now what is 1 over cosine? It's just equal to secant. Okay? So I don't want to leave it as a fraction, 1 over cosine, so instead I'll just put it in terms of secant and I will leave it. So again, if we run through that, 1 over tangent, 1 plus tangent squared, replace it with secant squared. Cosine times secant squared, I'm going to put everything in terms of cosine, and I will cancel accordingly, and I'm just left with secant at the end. Okay, more of a challenging example. Like I said, nothing totally new today, except for maybe this last example. What I'm having you guys do is on the worksheet assignment that I post, you only have to do 1 through 4. So 1 through 4 and 7 through 9. Show all your work. This is just like an additional day of practice. And we'll go on from here. We'll learn a little bit something new tomorrow, and you'll have a few problems, and we'll continue this pattern. So like I said, you guys keep up the good work. Make sure you check over your homework from last night. You fill out that Google form with how you thought you did on the homework and a reflection. And then you watch this video and complete those few homework problems off that worksheet. You will find the worksheet under the assignment tab. If you have any questions, feel free to reach out to me. I will be as accessible as I possibly can and answer them as quickly as I can. I hope everyone stays happy and healthy and have a wonderful day.